Exponential functions part 7. We have 5 basic rules. These rules can be used without proof. You can use these rules directly, but in this session I want to prove these 5 rules. Limit as x tends to plus infinity of ex equals plus infinity. Limit as x tends to minus infinity of ex equals to 0. Limit as x tends to plus infinity of ex over x equals plus infinity. Limit as x tends to minus infinity of x ex equals to 0. And limit as x tends to 0 of ex minus 1 over x equals to 1. The first two rules can be seen directly from the first video. I want to prove the other 3 rules. Limit as x tends to plus infinity of ex over x equals plus infinity. Proof. The limit as x tends to plus infinity of ex over x equals plus infinity over plus infinity, because the limit of ex at plus infinity is plus infinity, which is indeterminate form. Here we can apply Hopital's rule. The derivative of ex is ex, and the derivative of x equals to 1. So we get limit as x tends to plus infinity of ex over 1, which is plus infinity. Limit as x tends to minus infinity of x ex equals to 0. If we substitute, we get minus infinity times 0. Why we get 0? Because limit as x tends to minus infinity of ex equals to 0. Here we cannot apply Hopital's rule. So we transfer the exponential from the numerator to the denominator. So limit as x tends to minus infinity of x ex equals limit as x tends to minus infinity of x over e power minus x. If we substitute here, we get minus infinity over e power minus infinity is e plus infinity, which is plus infinity. So it is indeterminate form, but here we can apply Hopital's rule. The derivative of x is 1, and the derivative of e power minus x is minus e minus x, because the derivative of e power u is u prime e u. So back to the limit, we get 1 over minus infinity, which is 0. Limit as x tends to 0 of ex minus 1 over x equals to 1. If we substitute, we get e power 0 minus 1, which is 0, over 0, indeterminate form. We can make Hopital's rule. The derivative of ex is ex, the derivative of 1 is 0, the derivative of x is 1. So we get limit as x tends to 0 of ex, which is e power 0, which is 1.